Hello students, in this video let us discuss some important properties of Laplace transform and its problems. This is very important for exams. The properties are: if Laplace transform of f of t is equal to f of s, then Laplace transform of e power at f of t is f of s minus a. This is called first shifting property. So this is very important. Suppose if you have e power minus at f of t, then it can be written as f of s plus a. Then it means we in the Laplace transform of f of t, we are replacing s to s minus a, identifying what is a given from the exponential term. The second property we call multiplication by t. So that is given by Laplace transform of t power n f of t is equal to minus 1 power n based upon n value given, where n is a positive integer here. So differentiation, nth differentiation with respect to s of f of s, where f of s is what? Laplace transform of f of t. The third property is divide by t. Property called divide by t. So here the Laplace transform of f of t by t is equal to integral s to infinity f of s ds. F of s is Laplace transform of f of t. In all these three properties, we have to take what is f of t given, and we have to obtain Laplace transform of f of t. In the shifting property, we have to change s to shift s to s minus a. When you multiply by t, we have to differentiate, and if you divide by t given, so we have to integrate. That we have to remember. Now let's solve some problems to understand the properties easily, and these type of problems are important for your exams. So firstly, we have the problem: find Laplace transform of e power minus 3t sin 2t. This is in which format we have? E power at into f of t. E power at into f of t. Okay, so Laplace transform of e power at into f of t. It's a first shifting property. This is given by f of s minus a. F of s minus a. Nothing but. So we have to find f of s. What is f of s? It's a Laplace transform of f of t, and then we need to shift s to s minus a. So in the given problem, Laplace transform of e power minus 3t into sin 2t. What is f of t? So f of t is sin 2t. So we have to find f of s, nothing but Laplace transform of f of t, that is sin 2t. Then we have to shift s to s minus a, where a is given minus 3. So therefore minus of minus 3 plus 3. Then we obtain what is Laplace transform of sin 2t. So that is 2 divided by s square plus 2 square, it is 4. Generally Laplace transform of sin at is a divided by s square plus a square. Here a is 2. So therefore 2 divided by s square plus 4. Then we have to shift in this result s to s plus 3. So finally, while you are shifting s to s plus 3, the final result will become 2 divided by s plus 3 whole square plus 4. So this is how we have to apply the shifting property when you are solving the Laplace transform of the function. Now let us solve another problem by the shifting property. So given is Laplace transform of e power 2t cos square t to find. So we have the problem Laplace transform of e power 2t into cos square t. So according to the shifting property, f of t is cos square t. So we have to find Laplace transform of cos square t. Then we have to shift s to s minus a, where a is what? A is 2. So s to s minus 2. Now you cannot find Laplace transform of cos square t directly. So this should be solved. So So we know the identity. What is cos square t? This is 1 plus cos 2t divided by 2. Then we take 1 by 2 common out. So let us take Laplace transform of 1 and Laplace transform of cos 2t. So what is Laplace transform of 1? That is 1 by s. Next, Laplace transform of cos at is s divided by s square plus a square, where a is in our problem 2, 4, that will become 4. In this result, we are shifting s to s minus 2. So that is finally 1 by 2. So 1 by s minus 2 plus s minus 2 divided by s minus 2 whole square plus 4. Now let's take another example. So we have the problem here. Find Laplace transform of 4t plus 5 divided by e power 2t whole square. So given 4t plus 5 divided by e power 2t whole square can be written as 4t plus 5 whole square divided by e power 4t by squaring both numerator and denominator. And this can be written as Laplace transform of e power minus 4t, taking this to the numerator. Then 40 plus 5 whole square. So this is in the form of e power at into f of t. So we have to apply whenever we are observing e power at into the function t function. So we need to apply the first shifting property. So what you have to do, this is Laplace transform of 4t plus 5 whole square, and we have to shift s to s minus a, where a is minus 4 while you are shifting. So minus 4, because of minus 4 it will become s plus 4. Then so you can't obtain directly a Laplace transform of 4t plus 5 whole square. First we need to expand. So 4t plus 5 whole square can be written as 16t square plus 2 into 4 into 5. It is 40t, next 25, 5 square. So in this we are writing s2 shifting as s plus 4. Then it is 16 Laplace transform of t square. It is 2 factorial divided by s cube. Next, 40 Laplace transform of t, 1 factorial, because power is 1 here. Okay, 1 factorial divided by s square. Next, constant, we have 25 is a completely constant. So the constant divided by s. In the final result, we are shifting s to s plus 4. So then 16 into 2 factorial. 16 into 2, it's a 32 by s plus 4 whole cube. 40 divided by s plus 4 whole square plus 25 divided by s plus 4. So this is how you can apply the first shifting property. Now so far you have seen how the shifting property is applied. Now let's move to the second property, multiplication by t. So we have the problem here. So Laplace transform of t cos at. T into cos at. So when the function multiplied by t, we have to take the second property. That generally the second property is Laplace transform of t power n f of t is equal to minus 1 power n with d by ds. So with respect to n times f of s, where f of s is Laplace transform of f of t. So here first identify what is the given f of t. So we have t cos at. So t into cos at. So you can consider this is t power 1 into f of t cos at. Means f of t is cos at. F of t is cos at. So let us note down what is f of t given. It's a cos at, and let us obtain Laplace transform of the given f of t is considered f of s given by the formula s by s square plus a square. Now according to the multiplication by t property, since n is 1 here, so minus 1 power 1 is a minus, and one time differentiation, that is d by ds of f of s, means Laplace transform of f of t is s by s square plus a square. Now we have to differentiate this with respect to s, so we have to apply the quotient rule. So take denominator here s square plus a square, and differentiation of the numerator s is 1, minus numerator keeping as it is, differentiation of the denominator 2s, divide by denominator square s square plus a square whole square, and this minus sign written here. Next we simplify this further, minus keeping as it is. Now you can observe that s square minus 2s square can be written as minus s square and plus a square. So divide by s square plus a square whole square. So this is the result, Laplace transform of t into cos a t. Let's solve another problem by the multiplication by t, and also we have here exponential term. So here both the properties are applied. You can consider either the second property format first or the first property, shifting property. So better we go for identifying any exponential term given. We always observe that the given function in the format of e power 8 into f of t, means we apply the shifting property at the end. It is a simple. So otherwise you may find difficult when you are doing the differentiation when you apply the shifting property first. So let us consider e power 8 into f of t form. Then it will be the f of t become t into sine 4t. Okay, first we take what is Laplace transform of sine 4t, that is 4 divided by s square plus 16. Then we take what is Laplace transform of t sine 4t. So what is the formula for t power n f of t? Laplace transform of t power n into f of t is, in general, it is minus 1 power n, nth differentiation with respect to s of f of s. Okay, now we consider t into sine 4t Laplace transform first. So we need to apply the multiplication by t property. So let us take power of t is what? 1. N is 1. So therefore minus 1 power n become minus. Then nth differentiation means first differentiation with respect to s of what? F of s. What is f of s? Nothing but here a Laplace transform of f of t. Here what is f of t? Sine 4t. So Laplace transform of sine 4t is what? 4 divided by s square plus 16. Then we do differentiation, keeping this minus as it is, minus 4 as it is. We take this minus 4 out, and we differentiate 1 divided by s square plus 16, that is minus 2s divided by s square plus 16 whole square. So this can be written as 8s divided by s square plus 16 whole square on simplification. Next we have to find Laplace transform of e power minus 2t t sine 4t. Final result will let us find. So now we have to apply the shifting property e power 8 into f of t format. So it means this is Laplace transform of e power minus 2t. F of t we are taking now t into sine 4t. So according to the result, we have to take Laplace transform of f of t. In this format, Laplace transform of f of t means Laplace transform of t into sine 4t, and we have to shift what? S to s minus a, where a is what? Minus 2. So shift s to s plus 2. Therefore, we have already what is Laplace transform of t sine 4t. In that result, we are going to shift s to s plus 2. So therefore, it becomes 8 into s plus 2 divided by s plus 2 whole square plus 16 whole square. This is the result of Laplace transform of t e power minus 2t sine 4t. So till now we have discussed shifting property and multiplication by t property problems. Now let's move on to the third property, that is divide by t property. So we have here the problem, solve Laplace transform of sin a t divided by t. This is in the form of Laplace transform of f of t divided by t. So the formula is given by integral s to infinity f of s ds. f of s ds. So accordingly, we have now Laplace transform of sin a t by t, where f of t is what? Sin a t. Therefore, it is given by integral s to infinity Laplace transform of f of s means Laplace transform of f of t. What is f of t in our problem? Sin a t. So therefore, it is Laplace transform of sin a t with respect to s. So we know the formula of Laplace transform of sin a t. It is a divided by s square plus a square ds. Now we integrate this with respect to s. So a keeping out, it is in the form of 1 divided by x square plus a square. So we know the formula, integral 1 by x square plus a square dx. So that is 1 by a tan inverse x by a. So therefore we have here this a keeping out 1 by a tan inverse s by a and apply the limits. So applying the upper limit, this a gets cancelled, applying the upper limit we get tan inverse infinity, applying lower limit taking minus sign tan inverse s by a. We are applying s to s lower limit. So we know that tan inverse infinity is pi by 2 and we keep this as it is, and we have the standard identity pi by 2 minus tan inverse theta is cot inverse theta. Therefore, this can be written as cot inverse s by a. This is one of the important problem, and by the third property, that is divide by t. Let's see one more problem, very important, by the third property, that is divide by t. So we have here the problem, find Laplace transform of cos 2t minus cos 3t divided by t. So this is in the form of f of t by t. So formula is integral s to infinity Laplace transform of f of t, that is cos 2t minus cos 3t with respect to s. So now let us write the result of Laplace transform of cos 2t and cos 3t, that is under the integral sign, integral s to infinity Laplace transform of cos 2t is s divided by s square plus 4, that is 2 square, and other one s divided by s square plus 9. Now integrate this with respect to s. So this is in the form of integral f dash s by f of s. If you multiply and divide by 2 for both, so then it will be f dash s by f of s can be written as log f of s with respect to s. So or you can use the substitution procedure where s square plus 4 equal to t, then it will be 2s ds will be dt. So that procedure also you can apply. Then the result of this integration is log of s square plus 4. Similarly, this is minus log of s square plus 9. And we apply the limits s to infinity. But when you are applying the limits, upper limit, log infinity. So what is the value log infinity? Log infinity is infinity. Avoiding this to getting the infinity value, let us apply the property of logarithm here. So that log s square plus 4 divided by s square plus 9. So it is in the form of log m minus log n. Can be written as log m divided by n. So that is, we are writing here 1 by 2 log s square plus 4 divided by s square plus 9. Then applying the s to infinity limit, keeping as it is. again there is a problem. It is in the form of indeterminate. If you apply the upper limit, infinity by infinity, again you can avoid it, because whenever the term, any term tends to infinity, the reciprocal of that term become 0. So infinity is not defined, but 0 is defined. So you can avoid the value infinity by making a reciprocal of s term. For that, what you can do, you can take s square common from both numerator and denominator under log. So if you take s square common from this group numerator, you get 1 plus 4 by s square. Similarly, if you take s square from the denominator, so 1 plus 9 by s square. So then this s square gets cancelled. This s square gets cancelled. So then you can avoid the infinity value, right? So infinity substituting here, 1 by 2 keeping as it is, applying upper limit, this part become 0, because s square is in the denominator. 4 by s square, 9 by s square become, when you are applying infinity, 0. Therefore, remaining is what? 1 by 1. So log 1 written, minus you are substituting lower limit, yes. Whenever you are substituting lower limit, we have to take minus, and you are substituting s to s place. So that is how you get log, this is 1 plus 4 by s square divided by 1 plus 9 by s square. And while you are substituting, you can simplify and write. So it can be written as s square plus 4 divided by s square, that is in the numerator. Similarly, s square plus 9, if you take LCM, divide by s square, because s square to s doesn't change the term. Then s square gets cancelled, you get the s square plus 4 divided by s square plus 9. Then since log 1 is 0, log 1 is 0, and you can take this minus to the power. So this can be written as 1 by 2 log of s square plus 4 divided by s square plus 9 power minus 1, because of this minus. So then it can be reversed, s square plus 9 divided by s square plus 4. Then because of this 1 by 2, you can take square root of s square plus 9 divided by s square plus 4. So this is the result, and this is very important for the exams.